So 6.5, now we're on getting into more solving. Okay. How do you solve a polynomial with degrees higher than 2? We did a little bit of this in chapter 5 when we did grouping. That would be a cubic instead of a quadratic. So we did deal with this a little bit. A lot of it's going to be the same. And two of the factoring methods that we're going to use, or primary use in this one, are going to be ones that we already did in chapter 5. Okay. X to the fourth minus 49. Now the only difference is this is going to be looking at something with degree of 4. Okay. It's still two terms. There's not a greatest common factor, so we're just looking at two terms. It's difference of squares. The square root of x to the fourth is x squared. The square root of 49, oops, sorry, that's b, is 7. So we're still using difference of squares. X squared minus 7, x squared plus 7, and we're setting those equal to 0 and solve. So we would have x equals plus minus square root of 7 over here. Subtract 7, and we get, since it's square root of negative 7, plus minus I square root of 7. Okay, so we are using 5.3 to find the square root once we get it down. After we factor, we set them equal to 0. So there is a little more work. We're putting our chapters together, all those skills together, and find the solutions here. For x to the fourth plus 4x squared plus 3, it's the same thing. From chapter 5, we used the trinomial and the two binomials. It's the same work here. You just need to watch your exponents. Okay, so we did factor things like this before. X squared plus 3, x squared plus 1. And just like before, we're going to set them equal to 0, just like we did up here. And solve. We should get plus minus I square root of 3. And over here we subtract, you should get plus minus I. So we still get our 4 solutions we end up with. Remember, positive, negative is going to be 2 solutions. So these methods shouldn't be new to you. They are things that we should have done in chapter 5, so we should feel pretty confident in doing that. Solving these equations, we should feel confident. That's 5.3, find the square root. Now the new skill that we are going to get from this section is going to be factoring cubes. So the factoring cubes formula is going to be 2 different formulas. Okay? We have the sum of 2 cubes and the difference of 2 cubes. I do feel like this is pretty similar to the difference of squares. You're going to start with your problem, and there's going to be a formula you're going to use to factor it. Okay? Now for the sum of 2 cubes, we start with 2 cubes, a cubed plus b cubed, and since it's sum, we have addition in the middle. Factoring it, same way as before, you're going to have to figure out what your a and b is. Now we're dealing with cubes this time, so you do have to kind of think about what are your perfect cubes. Okay, 2 cubed, 3 cubed, 4 cubed. What are those values? And those are the cubes that you're going to want to look for. Okay, so there's functions on your calculator to help you with that, but that's something you're going to become familiar with. Now once you identify your a and your b, the formula a plus b, a squared minus ab plus b squared is the formula you're going to plug into. Take your time when you're simplifying everything. It's a little bigger than the difference of squares, but the same concept. Plug in your a, plug in your b, and simplify what you can. For the difference of squares, instead of a cubed plus b cubed, it's a cubed minus b cubed. The formula is a little different. The first leading polynomial here that we have, the binomial, it's a minus b, a squared plus ab plus b squared. Okay, so notice the pluses and minuses. Okay, for the differences, we have minus in the first one. For the sums, we have the plus in the first one. The back one, it's always plus b squared. So that stays the same. You're going to have to become familiar with these 2 formulas. Okay, so look at an example here. We have x cubed minus 27. Now instead of taking the square root of both sides, of both pieces, we're going to take the cube root of both sides. So your a is going to be x. They cancel each other out, so we're left with just x. Our b, the cube root of 27, either plug in your calculator or no. The cube root of 27 is 3. So also think about what the formula is. A minus b, a squared plus ab plus b squared. So take your time as you're going through this work plugging in. x minus 3, x squared plus x times 3 plus 3 squared. And now simplify and clean things up a little bit. X minus 3, x squared plus 3x plus 9. Okay, just writing this piece a little nicer, 3x instead of x times 3, and doing 3 squared getting us our 9. Okay, so pay attention to your plus and minuses, A, B, and then plug in and simplify. Here we have 27x cubed plus 64. So I'm going to start off again. Cube root. Cube root, be careful this time with the cube root. Make sure you take that cube root of 27. Your A is 3x. Our B is going to be 4. Again, you guys have calculators, use them, but you're going to want to become familiar with your perfect cubes. It's just going to make your life a little easier. Now this time it is the sum of two cubes. So the formula this time, A plus B, A squared minus AB plus B squared. Take everything and plug it in. 3x plus 4. 3x squared. Now notice my 3x squared here. I put that 3x in parentheses. 3x times 4 plus 4 squared. Okay, so this back one has a little bit more to simplify this time. Because that 3x, it does get a little more complicated. The front one should be easy. That one there shouldn't be mistaken. 3x plus 4. Here, everything needs to be brought to the second power. Remember your exponent properties. 9x squared minus 12x, multiplying 3x times 4, plus 16. And there's your factored form. So there's a little bit more to deal with here. You have that 3x, the whole thing needs to be squared. A little more to multiply there in the middle as well. Okay? So that's factoring it. Using that new method now, we can solve some cube problems. Okay? So here's one that we looked at before, but now I'm going to ask you to solve. Both those two things I just showed were just factoring. Okay? Now we're going to actually have to solve these. So we already factored this once. When we factored it before, you can go back a little bit and look at it. It was x minus 3, x squared minus 3x plus 9. Now to solve, we're doing the same thing as we did before. We are going to set each piece equal to 0. Okay? And once you set it equal to 0, you're solving that equation. These are equations we should be able to solve. X equals 3. Now over here, we do have the quadratic formula. So the quadratic formula, factor it. Somehow you have to be able to solve this quadratic equation. I'm going to use the quadratic formula. Okay, so we have all that simplify, or all that set up, so now we just need to simplify it. We should get 3 plus minus, that should end up being, I believe, negative 27. I'm going to check my work over here. Yep, negative 27 looks good. Divide by 2. Factor tree for negative 27. Okay, so this is something we need to start getting pretty quick at. It's negative, so there's going to be an I. Square root of 9, square root of 3. It's going to be 3 square root of 3. So when I rewrite this, 3 plus minus 3i square root of 3 divided by 2. Now you should, as I would suggest, break up into smaller fractions. 3 over 2 plus minus 3i square root of 3 over 2. And now this just helps you see, can anything be simplified? 3 over 2 can't be simplified. 3 over 2 can't be simplified. There's 2 of your solutions, and there's another one over there. Okay, so a little bigger, a little bit of solving with the quadratic formula. Okay, so take your time when you're factoring and think about what do the equations look like. Think about all the skills we have. That's what we need to start doing is, as we're going through these chapters, building up our toolboxes of ways to solve equations. Okay, now that one, we already factored that one, so let's do one more example. And this time I have not factored this one yet. So it's one more example. You'll see how to factor it, and we'll do one more example of solving. Cube root, cube root. So we should have a being 5x, b being 4. It's plus, so it's on the a plus b. A squared minus ab plus b squared. And plugging all this in, 5x plus 4. 5x squared minus 5x times 4 plus 4 squared. Simplifying some things, 5x plus 4, 25x squared minus 20x plus 16. Okay, so we do have some big numbers we're going to have to deal with here. Okay, just make sure you simplify everything nicely, make sure you have the correct signs. Since it's a sum, it's going to be plus, minus, and then plus at the very end like always. 5x plus 4 equals 0. Let's get that one out of the way. Subtract the 4, and it should be negative 4 divided by 5. So there's our one solution. Over here now, 25x squared minus 20x plus 16 equals 0. And I'm going to do the quadratic formula again. Okay? I'm going to tell you a lot of times these will not work out nicely, so factoring is going to be very rare to be able to do here. I'm not saying it's never going to happen, but I feel like the quadratic formula is nicer because it's always going to get us our solutions. Okay, so you can see with the 25 there, the 20, we're going to have a pretty big numbers to deal with here. So we have two negatives, we get 20. Now I'm going to check my work there for underneath. I have this done already. Should be negative 1200. So we're going to have 20 plus minus 1200 divided by 50. Okay, and it should be, oh, I'm sorry, it should be negative 1200 underneath. Okay. Now the factor tree for this should be 403. Square root of 400 is 20, so I'm going to rewrite this as 20 plus minus 20i square root of 3 divided by 50. Small fractions, just make sure you can simplify. 20 over 50 plus minus 20i square root of 3 over 50. And to simplify our fractions, 2 over 5 plus minus 2i square root of 3 over 5. 1, 2 solutions, and we found our other solution over here. Okay? So, one thing I want you to look at here is the new skill of factoring a cube, how to solve once we do factor the cube. And I also want you to go take a look at the degree of every equation we solved here. Look at the degree and look at how many solutions we ended up with. Okay, that's going to be something that moves into 6.6 and 6.7 in the next couple of videos.